All right, this is the second part of our section 9.1. We're going to talk about a couple of special right triangles. The first type is a 45, 45, 90. And you can see why. We have a 45-degree angle, a 45-degree angle, and a 90-degree angle down here in the corner. So 45, 45, 90 right triangle. First of all, I want you to recognize that a 45, 45, 90 right triangle is always half of a square. So what we have when we chop a square in half, when we draw that diagonal of the square, we have an A and an A and an A and an A. We have two triangles that are the same size, and that diagonal splits the square into two congruent triangles. Congruent meaning they're the same size. That puts a 45 here, a 45 here. When you have a triangle like this is an isosceles triangle. So I want you to remember isosceles means we have two sides that are the same length. So the A and the B are the same. The legs of this 45, 45, 90 right triangle are exactly the same length. The A equals the B or the B equals the A. All right, so in that 45, 45, 90 right triangle, the two legs are the same length. What we also need to recognize is that the C squared is A squared plus B squared, but A and B are the same, so I've got 2A squared. That, when I take the square root of both sides, I get C equals the square root of 2A squared, or C equals, the A squared comes out as an A, 2 stays underneath. I have C equals A times the square root of 2. So the hypotenuse here is A times the square root of 2. So we've got these relationships that we're going to use. In the 45, 45, 90 right triangle, the two legs are always the same length, and the hypotenuse is leg times the square root of 2. So if we know a leg of the 45, 45, 90 right triangle, we can find the other two, the length of the other two sides. If I know the length of the hypotenuse of this type of special right triangle, the 45, 45, 90, I can find the length of the leg by dividing by the square root of 2. And we'll get to some examples in just a little bit. The other type of special right triangle that we have is the 30, 60, 90. Now, what I want to look at there is if I took this 30, 60, 90 right triangle and I put another one just underneath it. So I have a 60 degree here, I have an A, I have a C, I have a B. It's a right angle. What I've created is an equilateral triangle, because it's got, if I look at the big triangle right here, let me change colors here for a second. If I look at the big triangle, it has three angles that are 60 degrees. That makes it equilateral, which means all the sides are the same length. An equilateral triangle, the sides are all the same length. So what we have is we have that 2A equals C, right? So the hypotenuse of this 30, 60, 90 right triangle is double the A. And notice the A is the short leg. So the A is the short leg. The shortest side is always opposite the smallest angle. In a triangle, the shortest side is always opposite the smallest angle. So the short leg, when I double it, I get the hypotenuse. The relationship between the B and the A is that B is A times the square root of 3. Now, point of reference, guys, square root of 2 is about 1.4. So on the 45, 45, 90, my hypotenuse is about 1.4 times the leg. On this one, square root of 3 is about 1.7. Okay? Square root of 3 is about 1.7. You can write that somewhere if you want to. Square root of 3 is about 1.7, approximately. So short leg times the square root of 3, or about 1.7 times the short leg, will equal the longer leg. This is the longer leg, right? Okay, so now where does that square root of 3 come from? Let's look at that really quick. So in this triangle, I have, we see why the 2a is equal to the c, I hope. I hope we see that. So c squared, let me solve it for, let's look at this. A squared plus b squared equals c squared, Pythagorean theorem. So if I subtract an a squared, I have b squared equals c squared minus a squared, right? But if a doubled is c, then I have, let me just replace the c with the 2a. That's what it's equal to. So that gets me 4a squared minus a squared, which is 3a squared. So in other words, if I take the square root of both sides of that, b is the square root of 3a squared. The a squared comes out as an a, and I have b equals a times the square root of 3. It's just from the Pythagorean theorem. These relationships come from the Pythagorean theorem. Now, what we're going to do is we're going to talk about how to find the other two sides if I know just one of the sides of these special triangles. Because if I know one, I can find the other two. So that's what we'll be doing next. We'll talk about how to find the other two sides if we're given one in this special right triangle. And it's really pretty easy. So let's talk about how that works. All right, so for the examples below, find the measure of the missing sides. Leave your answer in simplified radical form. So in example 1, we have a 45, 45, 90 right triangle. It's important that we have that right angle. Well, it wouldn't have to be marked, would it? Because the sum of the three angles of a triangle is 180. So if I have a 45 and a 45, that means there has to be a 90-degree angle for my third and final angle. Okay, so what we're going to do, in this right triangle, I'm going to find the y first. The y is the other leg. It has to equal the 8 radical 2. The two legs have to be the same size, same length. So y equals 8 square roots of 2. The x, I'll work on that one a little bit harder. X is the leg times the square root of 2. Because the x is my hypotenuse. Okay, so my hypotenuse is going to be 8 square roots of 2, the length of the leg, times the square root of 2. So if we simplify that, square root of 2 times the square root of 2 is 2, and 8 times 2 is 16. So my hypotenuse is a 16. My other leg is 8 square roots of 2. And we're done. Right, problem number 2, or example number 2. The x and the y are equal. It's the first thing we're going to notice. 45, 45, 90. The two legs are the same. It's an isosceles triangle. So I have the hypotenuse. I know that the hypotenuse is x times the square root of 2. The leg times the square root of 2 will get me the length of the hypotenuse. That was our relationship, right? Leg times the square root of 2 gets me the length of the hypotenuse. So, and I could use the y just as easily, right? So I have x square root of 2 equals 6. I'm going to divide both sides of that equation by the square root of 2. So notice, if I have the hypotenuse, divide the hypotenuse by the square root of 2, we get the x value. Now we're going to rationalize that denominator because it's a good idea. You don't like having radicals in the denominator. So we'll rationalize. So remember how we do that. We multiply the numerator and denominator by the square root of 2. So we get 6 square root of 2 over 2, and we reduce that to 3 square root of 2. All right, so x is 3 square root of 2. Let me clean that up just a little bit. and y is also 3 square root of 2. They are equal. So that's our solution for problem number 2. Okay, let's do a couple of the 30, 60, 90s. All right, so in my right triangle, the 30, 60, 90, the relationship we need to remember is this is double the short leg. Notice where the short leg is. It's opposite the 30-degree angle. Shortest side of a triangle is always opposite the smallest angle. So we have 2x equals 12 square roots of 6. We'll divide both sides of that equation by 2. And we'll have that x is 6 square roots of 6. Once I have the short leg, so really the technique for solving or finding the lengths of the missing sides of a 30, 60, 90 is get that short leg first. So if we have the short leg, we then multiply it by the square root of 3, and we get the length of the longer leg. So the y is going to equal the x times the square root of 3. Okay, square root of 6 times the square root of 3 is the square root of 18. Because 18 is 9 times 2, I can bring the 9 out as a 3. 3 times 6 is 18. 2 stays underneath, so we have 18 times the square root of 2 for the length of the long leg. So y equals 18 square root of 2, x equals 6 square root of 6, and we're done. All right. Problem number 4, example number 4, another 30, 60, 90 right triangle. Notice this time I have the short leg. It's opposite the 30-degree angles. That's my short leg. So x is going to be 2 times 5 square roots of 2. In other words, x is 10 square roots of 2, 10 times the square root of 2. Let's find the y. The y is just going to be the short leg times the square root of 3. So the y is going to equal 5. Square root of 2 times square root of 3 is square root of 6. And we're done. It's easiest if you have that short leg. If you don't have the short leg, find it first. Okay? By doing some dividing, because we know the relationship between them. And to undo multiply, we divide. So let's look at example 5. 30, 60, 90, right triangle. This time I have the long leg. The short leg is the x. So remember that x times the square root of 3 will get me from the short leg to the long leg. Okay? So I've got x times the square root of 3 equals 4 times the square root of 3. If I divide both sides of that equation by the square root of 3, I will have the x. So x equals 4. And then for the y value, that's the hypotenuse. The hypotenuse is always double the short leg, so this is 2 times x. Okay, see how we're using these relationships between the lengths of the short leg, long leg, and hypotenuse? Okay, so double the short leg, we get the long leg, so y equals 8. And that is our special right triangles.